Hey, what's up, YouTube? Welcome back to No Pros Garage. Today we're going to jump right into it. You guys wanted it, you guys asked for it, today you got it. We're going to show you how to read wiring diagrams. Stay tuned, we'll show you how to get it done. Alright, so let's get right down to it. First, let's go to 2010 Jeep truck Liberty. Okay, we'll go into wiring diagrams. Now, I want to just point out a couple things here first. The first option you see here is fluid, which we're not going to get into any of that. It's just going to show you, at least on this vehicle, something like the transmission solenoids and actuators, the way their fluid runs, or some vehicles will show you brake lines, the way that fluid runs, like the paths that they take. We're not going to get into that, but I just want to notate the first option when you get under diagrams is fluid. Okay, you have exploded views, vacuum and vapor hose. This is where the big difference comes in between the manufacturers. So diagram information and instructions. You click in here, you click vehicle systems. Now, this has three options: circuit functions, circuit information, and general warnings. Okay. The circuit information, if you go in there, it gives you some good information showing you this is a good chart to have, number one. So if you want to take out a phone and screenshot it, or if you can figure out a way to save it and print it, I highly recommend doing that depending on the car that you're working on. So, and I'll get into what I mean in a minute. Not all of the different cars and different manufacturers will offer this chart. However, for all data, all of these abbreviations for the colors mean that color on just about every manufacturer in here. Okay, so that's a good one to take a screenshot of, especially if you don't have a Jeep, or I don't know if Dodge does it, or Chrysler, but you catch my drift. So now you go back into circuit functions, and this is again another very good chart to have that I know for a fact all of the manufacturers don't have, but it does relate the same to each specific car. So as you're going to see in the diagrams, you're going to have a letter next to a lot of stuff. Okay. And they're going to relate to this system in the vehicle on the wiring diagram. Okay, so circuit A is a battery feed. Circuit Z, if you happen to see one, is a ground. Okay. Now I apologize too for the difference in my voice and the sound. The camera died, so now I'm doing it off of an external mic from my computer, and I know it sounds a little weird, so I apologize for that. Anyway, so let's go back to a different vehicle here. Now we'll go to a 2010 Ford, okay? And we'll go to diagrams, and what you're going to see here is the first one is diagnostics aid, which we did not even have in the Jeep at all. So you go in here, and this will teach you how to repair connectors and terminals. Cut them, splice them, solder them, whatever the case may be. So again, the whole purpose of this is just to show you that every manufacturer offers different stuff. So if I'm showing you stuff on here today that you don't have in the vehicle that you're looking at, I don't want you to get discouraged or think there's anything wrong with your plan, meaning your all data subscription or anything like that. It's just manufacturer specific. Okay, so here is the first important thing to know in order to read wiring diagrams. Now, this is going to be a pretty lengthy video because there's a lot to cover, and I'm going to try and do it in the most basic way that I can. So just do yourselves a favor. If you really want to learn, just hang out and stick it out to the end. I promise you it'll be worth it. Okay, so this is a fuse symbol, right? A little squiggly line with two dots. It's pretty generic. The battery is also pretty generic and self-explanatory. You have a positive side and negative side. but they don't always show up like this, okay? These are very generic wiring diagrams and symbols. So this is a heating element that you would see in like oxygen sensors that have heater circuits with them. This is a potentiometer. Okay, so basically this resistor here, it's just a bunch of like sawtooth lines. Okay, the potentiometer will have a line basically with an arrow going through it to show you that that's basically a variable resistor is what that is. Okay, and where that needle points, you're not going to see this in a wiring diagram, but basically that's how that type of sensor works, is they will have a component that passes over the resistor. It moves back and forth and either raises it or lowers it, and that's how you change your values of your voltage or your amperage, whatever you're reading. Okay, so that's again something for another day. But a symbol like this arrow means it's a connector. Depending on there you go. Depending on how you see it, one way is a female connector, the other way is the male connector. Right, one arrow going up towards the wire, the other one going down away from the wire. That's the difference. Okay, so let's go back and we'll go into another set of symbols here. So a coil assembly, it's pretty important to know. You have what looks like a bunch of like M's to imitate a coil. Okay, so you have ignition coil or you have a solenoid, which they'll be very similar to a lot of relays because relays have coils in them to be magnetized. That's how they work. So you'll see that symbol quite often. All right, diodes, they're basically a check valve where electricity can only flow one way. So this is a LED light, and the difference here is you have a circle around your diode symbol. So for a regular diode symbol is just a triangle with the line underneath it here. As you can see here, just kind of all encapsulated in that circle. So fusible links, they're pretty self-explanatory. They're basically a different style of fuse that goes in line with the wire in question. Okay, a shield, you'll see this symbol if a wire has a specific type of insulation around it or has multiple wires, things of that sort. And I'm not talking about your regular plastic wire loom. I'm talking about an actual insulated type of shield. Okay, that's what that means. So let's go to another set of symbols. And again, not every car manufacturer is going to have these options to show you these symbols. So if you can, take a screenshot or do whatever you have to do. It's very good information to have. Okay, they have your wire color coding. Let's see if there's anything important here. So here's the relay that I was talking about. So you have a control side and a load side on a relay. So in order for this switch to change position, this coil would have to be energized and magnetized, and it does that by the control side of the circuit. Okay, again, that's getting a little bit more in depth than we need to at the moment. Here's another fantastic chart to have. So this number, or these numbers, anything from 100 to 199 is going to be anywhere in your engine compartment. Anywhere from the 200s is going to be basically your firewall to like your front seat. I'd say that range. And so on and so forth, all the way down to about 900 is going to be as rear as you can get of your vehicle. All right, your tail lights and things like that. So take a screenshot if you want to or whatever. Very good diagram to have. So let's go back a little bit and remember what I'm talking about with these numbers. I'll show you this real quick. So let's go into our wiring diagrams. And for argument's sake, we'll just go into powertrain management, okay? So the first thing you're going to want to notice, let me zoom in a little bit. And give me a second while this loads up. There we go. All right, so I'm going to zoom in a little bit, make it a little easier to see. So the first thing we want to note is on a wiring diagram, the power will always be at the top of the page, okay, meaning your fuses, battery, if it comes directly from the battery, whatever your source of power is, the power will be on the top of the page. And if you are to go and scroll down, your grounds, your external grounds, will be on the bottom of the page. If there are no external grounds, then they could be anywhere. They'll be inside of a module, anywhere on the page, depending where they're showing you that module, okay? So, for starters, the first thing you want to know is not every vehicle, again, and I have to keep repeating this because there's a lot of differences that are important to note, but they don't really make a difference. So right here, fuse 53, it's a 5 amp fuse. Now it doesn't tell you what circuit that is or what it goes to. It just gives you a number. Now in the case of my Chevy truck, it will give you what circuit it is. It'll give you a readout, actually. It'll say like engine coolant temp or so on and so forth. You get the point, but it won't give you that location. If you have a wiring diagram on your car like this one that's giving you a number, that is the location in the fuse box where that fuse is located, okay? So it brings me to the next thing. Any component you look at is going to be pretty much highlighted in this transparent blue, and it's going to give you a description on the side of it. Battery junction box, and it's going to tell you where it is. Front of engine, okay? That's your fuse box, basically this one, all right? Next thing to note, if you have a component such as this one that has dashed lines going around it, and this one, what that means is that there is more to this entire component right here than what you're seeing on this page, okay? Same thing with this one. So let's scroll down a little bit, and let's see, this is probably the PCM on the left-hand side. Yeah, it's a powertrain control module, okay? It's telling you exactly where it is, right rear of engine compartment. So there is more being plugged into or more circuits on this powertrain control module than they're showing you on this page that we're looking at, okay? That's what that dotted line means. So, going back here, you can see you have relays here, a relay. And these are the pinouts, 1, 2, 3, and 5, okay? On other manufacturers, they'll literally give you the pinouts that you would see in a car, meaning 86, 87, 85, stuff like that. So if you look at the, let's just say your TCS wire here, okay? These numbers that are on the outside of the component that you're looking at, they're the pinout. So if you were to go to your engine computer, you would find this number, which is C175B. That's the actual connector that goes into the PCM, because there's multiple connectors, probably 3, 4, whatever the case may be. So you find that connector, which I'll show you how to do that as well. And these are the 70 pins that are going to be part of that connector and that connector only, okay? So these numbers correspond with the pins. So let's see if I can scroll back out of here, and I'll try and search for that connector. See if I got that right. Connector 175B. So you click on that. Now it'll give you a pinout if it loads. Let's see why it's not showing you an actual picture. There we go. Okay, so let me X out of that, see if it'll Let me refresh this, see if that will actually show up. There we go. That's what we want to see. Okay, so let's just say, for example, let's look at, I'll just pick a number, pin number 9. It's not used, of course. Let's look at pin number 11, okay? Pin number 11, it's going to tell you right here what circuit it is. CCFO2. It's going to tell you what color the wire is. Okay, green and white. 20 gauge wire. And it's on 5.4 liter Fords. Okay. So let's go back now, and we're going to look for pin number 11, and we're going to see if that CCFO2 is correct and that green and white color is correct. Also, another thing to notate before we do that, this is very good to know if you can find these connector views very easily in the method that I just used. You take a look at the connector itself, the whole picture, and try and orientate. Now, this would be looking at the female side of the connector. If you took the connector apart and you looked inside the female side in the same direction, meaning you'd have this clip going off to the left-hand side, find some type of distinguishing characteristic about that connector so you can orientate it the same way in the picture to get your bearings straight, okay? So just say, for example, you look at this handle. This is probably a lock handle to keep it tightened to the engine computer. So if you look at the female side and you orientate that handle on your left-hand side, then you know that pin number 1 is your most top left pin, and pin 70 is your most bottom right. Okay, it's an easy way to clarify. So let's go back a little bit now, and we're going to go for pin 11, and we want to make sure that this information right here is correct. Okay, CCFO2 and green and white. So let's go back. We're back in engine controls. We're going to zoom again. Zoom a little more. Okay, we just said pin number 11. It's green and white. CCFO2. Okay, so you're going to know that when you take a look at that circuit, if that's what you're looking to work on, you'll know for sure that you were on the right connector. Now, sometimes I have seen the coloring in these diagrams be wrong compared to what your car actually is. A good way to tell is, number 1, you could be on a wrong connector. But number 2, take a look at the pins near it, next to it. Okay, if pin 10 has nothing in it and 9 and 8 have nothing in it, and then there's a yellow on the other side of your supposed green and white, if that yellow is there and you have 3 pins with no wires, and then on the other side of your green and white you do have a violet and white, then chances are you are on the right circuit. They just got the coloring wrong on the wiring diagram. That doesn't happen a lot, but it does happen. So don't go 100% certainty based off of this coloring. But if everything else aligns, if the circuit number aligns, the pin number aligns with what you're looking to work on, so we'll go forward a little bit, and that's a 4-wheel drive. I didn't really see too much of what there is, what they were describing here, so let's go back a little bit and see. Okay, so pin number 11, we know it's right because we just saw that number and we just saw the green and white. So it's a control module, okay, for the 4-wheel drive. So right there, it just describes everything that you just saw in the description of that component, okay? So let's go back here a little bit. Now, there's a lot to cover in the very beginning of reading wiring diagrams. That's why I'm spending so much time here, but I promise you it's worth it. So this would be, again, another separate component. This is the fuse box. So your fuses, as they leave the fuse box, It'll tell you what color it is depending what you're looking on, yada yada. Anytime you see a circle like this, that's a splice, okay? That means that there's more wires tying into that location. Same thing with the dashed line. That's just telling you that it's not showing you everything that's tied into that wire. Now what you'll notice here is you have these numbers, S103, S129, S101. Now remember that chart that I showed you before that has the 100 to 199 numbers that I told you to take a picture of? That's going to basically tell you in part, just by those 100s alone, I can tell you that that is in your engine bay. Okay, that's in the front of your car, anything from 100 to 199. And remember, we said the 900s are all the way in the back of your vehicle, and they go in sequential order. So let's see if I can't find anything else, and then we'll come back to this. I know I'm jumping around a little bit, but I promise you it'll make sense. Let's see if I can find another splice that is not up front. We may not be able to because we're in engine controls, but let's take a quick look. Okay, so far everything's up in the front of the motor, the front of the car, basically. Okay, so these are splices again, as I said. They'll start with an S number, or an S letter, and then give you a number. Now when you're looking at your grounds, they'll start with a G, but the numbering is the same exact thing. Anything with the numbers 100 is up in the front of the car, so it'll tell you right here, right front of engine compartment. If you get into the 400s and 500s, you're working your way towards the back of the car. That's where you need to be looking for those grounds, okay? So don't wait. If you see that number, don't waste your time up in the front of the car at all if you're in the 400s. Now here's a perfect example. If you need to look for this splice or this ground, look where it is, under left rear of vehicle. But just, I can tell that without that description, I can tell just by that number alone based on that chart. Do not waste your time looking up front in the engine compartment. This will be in the rear of the vehicle, somewhere in the rear of the vehicle. Okay? So right here, S200. Okay, that's going to be somewhere up by your front seat. Somewhere in that range, from your front seat to the inside of the firewall. Like where your OBD2 port is, and somewhere in that range is going to be where this splice is if you were looking for it. Okay? So that's all very good information to have. Now bring me to my next point in reading diagrams. You're going to see, and I think I talked about this already, you're going to see a component that has a dashed line. That means there's more to this component than just these two wires. It's not showing you this on this diagram. It'll be in another diagram, another circuit, whatever the case may be. However, when you see a solid one, that means that everything that circuit needs, that sensor, whatever it is you're looking at, it will all be right here. In this case, these 4 wires are the only thing that goes to this brake pedal switch. That's it. There's nothing more involved in that circuit. Okay? So over here, it's a good switch to look at, really, because it shows you a diode in here, which again, that's a one-way check valve, basically, for the electricity to flow. It can only go one way. So that's a resistor on this side and a diode on this side. Same thing on this part of the switch, a diode here and a resistor here. All right, so going back to our beginning diagram, some cars and manufacturers, you'll see the pin out, which is what that's called. Pin 52 is your reference, one of your reference circuits. But it's going to show you the circuit number again, and it will also have a number next to it, which would be a 2-digit number, and that will be your gauge of your wire, which is nice to know when you are looking at stuff and need to know, what you're working on, or if you got to replace a run of wire, you want to know what you need to replace it with or pick up at the store. Not all manufacturers show that. As you can see here, this one does not. So going down here, this is an external ground. And one thing you want to look for is every circuit needs three things, really. You need a power, you need a ground, okay, and you need a load somewhere in between there to take all that current flow. So if you want to know whether or not your system circuit that you're working on is ground side switched or power side switched, meaning when does this switch change position? Does it always have power and changes when the ground is applied to it? Or does it always have ground and it changes when the power is applied to it? Well, in order to figure that out, what you have to do is you take a look at one of your wires. If you know what one side of your wire is, let's say this, for 100% certainty, we know that this is power, right? We know that because it's fused, it's in the fuse box. This all has to be power up here. So if you follow this fuse down, let's see if it goes through a load. It doesn't, it goes right to the PCM. But anyway, whatever would have, the other side of that wire would have to be a ground. All right, so for example, let's take a look at one down here. So you have a reference wire, and you have a signal wire, and so the other wire has to be a ground, okay? Which on certain sensors you can share grounds like this is, and other sensors you cannot share grounds. So they'll be either grounded by the PCM, by whatever module they run to, or they'll be shared by an external ground like this. So as you can see, this fuel tank pressure sensor shares a ground with your mass airflow sensor and also with your pressure transducer sensor. Okay. Now, one of the biggest reasons they can share that is because they are all potentiometers, which a potentiometer is one of the symbols that looks like this. It'll have a resistor and it has a line near the resistor. That means that that line will work its way over back and forth on a resistor to change the values of your pressures in all of these. Okay. So they share a ground. Now, what you can see is, if you know that this is a ground, because that's what a signal return is. Signal return is another word for ground. Anytime you see can high or low, or anything that says high or low, high is the power side, low is the ground side. Okay, so they have a ton of different names for them. Some of them show you a minus and a plus. That's an easy way to know. Some of them say high and low. Low is always negative or ground, and high is always positive. Okay. Signal return is another way of saying ground as well. Feed is another way of saying power or supply, voltage supplied. It's another way of saying power. Okay. Those things can be tricky if you don't know that. So basically, let's take a look at this fuel pressure, fuel tank pressure, right? You got 3 wires coming out of it. As I said, we know one of them is a ground, right? Signal return is ground, which gets its ground from the computer ground, which you can see is external here. So the computer theoretically grounds the fuel tank pressure sensor, but the computer gets its own ground from the right side of the engine compartment. It's externally grounded, okay? So going back again, we know that this is a ground. So you're going to have a signal wire, which is this violet green. That's your signal wire. If you want to pick up and see what it's working on, this is the wire you would tap into. But you would also check and make sure that you have your 5-volt reference, which is what this wire is here. It's your fuel tank pressure reference, and that should be 5 volts. I say that's normal, but different cars have different reference systems, but there is always a 5-volt reference. And again, I shouldn't say always, but that's the most common. If there is any other ones that are uncommon and anybody knows what they are, I'd be curious to know which vehicles have different ones, because I have not come across any, but I have watched Scanner Danner. If you guys never watched his channel, or South Main Auto, I recommend taking a look at both of those guys. They are fantastic. They'll probably do a whole heck of a lot better at teaching you guys this stuff than I will, but they're definitely more advanced. I'm trying to do it on a more basic scale, but they'll be able to tell you more about 5-volt reference circuits, and if there are different reference circuits, meaning if you can have 7-volt references or 12-volt. I highly doubt it. If anybody knows and wants to comment and correct me on it, please do so. But for the sake of our arguments, we're going to stick with a 5-volt reference. So that's what this would be. Inside of your powertrain control module, your engine, or whatever module is running the sensor in question, they will have a regulator in them. So they will take the 12 volts from the battery and they will regulate it down to 5 volts. So that a good example would be really any one of these. They're all on 5-volt reference. It's just hard to pick one, but it'll take a 12-volt signal and turn it down to 5 volts. So any time the computer would sense this going over 5 volts, it would throw a code, right? That would be way too high voltage for that. In certain scenarios, which we're getting a little bit beyond the scope of what we're talking about today, you can actually have your sensors or other things fried if they get more than 12 volts. Not just throw a code, but they could actually get fried depending on the scenario. Okay, there's a lot involved with it. So let's try and check a different system. I'll try and find something a little easier. Let's check a headlight circuit. Let's go ahead and zoom in on that. All right, so once again, you see your fuse box here. You see that it's dashed lines. Why is that? Because when we were just in the powertrain control module diagram, we didn't see anything about headlights in there because it's not the circuit we were looking at, right? So that's all that is. That's showing you that there's more to this than is right here on this page. Here's a good example of what I was talking about with the pluses and minuses. MS CAN plus, that is positive voltage, okay? That's MS CAN negative, it's signal return, it's ground, it's all the same thing, okay? It's just worded different in different things, so don't let it throw you off. This symbol right here, I'm assuming is a transistor. It's a little type of switch inside a microboard or something. I haven't been able to find this symbol anywhere. A typical transistor looks kind of like this, except without this being a straight line, it's more of like a Y inside of this circle. So I'm assuming that this is their version of transistor. If anybody does know for sure, comment down below and let me know. But I believe these are transistors. All right, same thing here. So this is a relay. This is how your relays work. Basically, your relay, you need a control side, which would be over here, okay? And you need a load side, which would be this circuit here. So what's going to happen is this fuse, you can see it's hot at all times. Even when the car's off, it's hot. So when this power comes down, this power is going to come to this point and it's going to stop right there. So what I told you before is every circuit needs a power, a ground, and a load in between, okay? So this side is power. This is your load here. So the other side has to be a ground. So this wire going right here, this is grounded. Somehow, some way through this microprocessor, whatever this is, it's ground. So what's going to happen is when you turn your switch on, your headlight switch, and this board gets a signal that you're turning your lights on, it's going to apply ground to this line. I'll see if I can leave it highlighted. There you go. So the reason being, we know that this always has power. So what I was talking about before, this would be a ground side switched relay because it always has power on both sides of the relay, the load side and the control side. Okay? So what's going to happen is this always has power. When you go to turn your light switch on for your headlights, that's going to give this wire ground. Okay? Now when this wire gets ground and it meets this resistor, or this coil is what it is. It's a magnetized coil. When that magnet engages, it's going to pull this switch to this position. Okay, let me see if I can do something here real quick. So once that engages, it's going to pull this switch to this position right here. Yeah, that worked out well. Let me try that over. So it's going to pull this switch to this position. Okay. When it does that, you're going to get power sent down through this. Let me see if I can. There you go. Through this wire. Okay. Which is going to turn on your high beams. Okay. So right there you have it. Your high beam relay. All right. Let me go back and get rid of some of this mess that I made on here. I have a feeling that this would probably be a better video live to answer questions in live stream, and let me know if that's something that you guys want to see instead of me just babbling here and kind of making it a little more difficult than it has to be. Let me know if you guys want to do a live stream, and I can answer questions on the spot. That might help you guys out a ton too. So if you're interested in that, leave a comment, man. So let's follow down here. Let's go to our regular headlights and see if we can follow something back up. All right, so these are grounds. This is your ground for your headlamp switch. Let's see. Fog light off, parking light low, and auto. So I wonder if the way this is written, if low is your low beams. I'm assuming so. Again, I'm talking about this circuit right here. Right here. Okay. So when that switch gets closed, which now I'm going to assume, okay, this is going to be a power side switch. And the reason I say that is because if you follow, let me get rid of this. If you follow this wire that goes to ground, this is a constant ground. It's constantly grounded and it constantly wants to be in the off position. Why? Because your lights don't always stay on, right? So in a ground position where it's grounded constantly, your lights are off, which tells me that you need to turn or add power, give this wire here power in order to make that switch. So let's follow that back up. And let's see if where that blue and white wire goes. Click on it and highlight. Scroll back up. So that goes to your low beam. All right, so this micro board, whatever it is, and again, like I told you guys in the previous video, I'm not 100% sure on everything, but I do know enough that I can teach you guys to be able to read this stuff and get you pretty far along with your diagnostics. So whatever this micro is, I'm assuming it's a microprocessor, or on the like a circuit board, that when you hit your switch, it is supplying the power. So let's see. Okay, so again, it definitely has to be a board, because you're seeing here you have powers going to it from these fuses. Okay, but we also know for a fact, we said before, this is a ground, and you can see it in here. This has to be grounded through some way, shape, or form. Okay, so when you hit your switch to turn your high beams on, it's going to send power from your fuse through your transistor. Okay, which, let's see where that gets its power from. That's blue and green. Okay, and that's the one that goes to your low beams. That's your right headlamp. Okay, so let's see where, yeah, and it's not really showing you where the other side of that goes into, so it's not exactly the best example, and it may be a little confusing, so I apologize for that, but that's basically the concept behind it. That's the difference between circuit design. Whether it's a pull-up design, is when you need power to turn it on, it's going to pull it up to voltage, or if it's a pull-down design, it's going to pull everything down to ground when you apply ground to it. Okay? So let's see if we can find some other examples. So this symbol here, this is a light bulb. Okay. Let's see if I could find some other examples. Powers and grounds. Let's try going here. Power distribution. Okay, so here's a good example of earlier in the video. I showed you there was a little square wave symbol. It looks like that. That was a heater circuit. So that's a heater circuit here, and look what it's for. Cigar lighter. Okay. Another common place, like I said, that you'll see them is on most of the newer cars now. The oxygen sensors have heater circuits on them to help make them more emission efficient earlier. Like, as soon as you turn a car on, let's say, instead of waiting for the temperature gauge to get up halfway, the heater circuit helps with that on those oxygen sensors. All right, so same thing here, though. This is battery power. Now, when you see symbols like this, letter A, it's telling you that it's going to a different place. This is going to splice 110. Okay, so you can find splice 110. Let's see if it's anywhere on this page. Right here, okay? So all it's showing you, it can be confusing again, but that's what you would do, is you would just look for the other mate. So A is coming from up here, A, but all it is telling you that there's more to where these wires go. So it's going to splice 110. You look down here, and this is splice 110, okay? Then this will tell you where it's going from that splice. That's all that is. Now again, we'll go back and we'll look at, this is your smart junction box, which it's looking like it's the one in the passenger compartment, which would be in the passenger side of the car, down on the right-hand side. So in that fuse box, again, it's dashed line, so it's not complete here. This is your connector number, C2280G. These are your pin numbers on that connector. So this connector is 2280G. pin 29 is not used, but take a look, it's 2280D. So it's very important that you pay special attention to your connector numbers. Make sure you have them correct when you're going to diagnose. That makes all the difference in the world between a misdiagnosis or the proper one. And, blowing fuses because you stuck a pin in the wrong thing, or, not making mistakes. So again, here, same thing. Here's your connector number, and here's the pin on that connector number of the transfer case control module. Okay. Power running board module, there's a connector number, there's the pin number. All right, so this is the big fuse box. Everything that it's showing you here. And here's, again, another good example of the grounds. Ground 203, the 200 is going to be somewhere inside the front part of your car, okay? And, well, what are we looking at? We're looking at the cigar lighter. Where are they usually at? In the front. Some cars have them in the back seat, so it used to anyway years ago, but, the majority of them were in the front, and it even says front cigar lighter. So don't go wasting your time looking for a ground anywhere else. I'll tell you right here by the numbers what type of area they're in. Okay. It's a fusible link. That's just an inline fuse. All right. If there's anything else that you guys feel I did not cover today, or if I babbled too much and confused you instead of helping you, let me know, and maybe we'll do the live stream version of this. This way, whatever questions you have as they come to mind, I can answer you right then and there. Let's see if there's anything else I can show you of importance. I think we covered it all. I think we oversimplified really how easy it could have been. But there's such a ton of information that is put into these diagrams that are not hard to understand or pick up on at all if you can get the basics down. Okay. Real quick, I'll run over them again and try to not simplify it. The powers come from the top of the page. Okay. They run down to the bottom of the page where you'll see all of your external grounds. All right. The symbols, take a look at different cars, different manufacturers that you're working on. If you choose to get these accounts through ALLDATA, diodes, resistors, switches. Dashed line means there's more to the component than they're showing you. Solid line means that it's all, everything you see, it's all right there. Okay. The number next to the component is the pin number. This one obviously only has one connector going to it. Otherwise, it would give you a connector number somewhere in the corner. This little arrow here pointing towards the wire means it's a male connector. It is a connector. That's what this arrow and this arrow means. But there are the differences between the male and female connectors. Okay. See if we can find one. There's a good example. There's your connector numbers again, as I've used this example already, but you just pay attention, and this looks like a train wreck of information all in one spot, and it kind of really is, but just spitballing off the top of my head, and what I'm trying to get you guys comfortable with is what you're reading. Connector number, wire color, spliced, where the splice is, 230, okay? The dashed line, meaning that it's not complete. The pinout number, again, another connector number. Male connector, female connector. Okay, just means that it's that area is a connector. You're not looking for a solid wire. There's a connector that you can pull apart here and here. All right, so it's all simple stuff. This is also a connector, but it means it's going directly on a component. There's no run of unnecessary excess wire. It's going right to a component connector. Okay. Now you might have a couple inches worth of wiring that comes off the connector, like an oxygen sensor. You know, you might have a foot or 4 inches of wire off the oxygen sensor, but it won't show you that. It will show you the connector going right to the component. That's what that means. Okay. When you see arrows like this from fuse 12, letter C, all you're going to do is look for the letter C. Or if you see anything with fuse 12, right here, okay? Connector C, that's, you would make those two links together. You would look in both of those areas to follow and find your circuit. So again, that's going to wrap it up for me. I don't want to do any more boring to death than I already did for you guys. I hope it helped you. There's so much stuff we can go over. Again, let me know if you want me to do a different video, a better video that's less involved, or if you would like to do a live stream, you know, one-on-one or whatever the case is, and ask your questions at that moment. And I think it would help you get a better understanding. So let me know if this helped you. Let me know if you want to see something different. In the meantime, thanks for watching. Catch you next time. Okay, so I realized I was wrong before, and I just wanted to say one last thing. So looking at these diagrams that we were on before, I showed you guys these letters, and I talked about them a bit. But what I failed to mention was that what it says here, diagram 1 of 5, it's telling you where its counterpart is. So sometimes it will tell you if it's not even in this system, if this wire goes from this power distribution, if it goes to, let's just say for argument's sake, if it goes to your radio, it would say to radio diagram. Okay, so being that this is all still in the same group of diagrams, which is this power distribution, it's only telling you the page that it's on. So we'll look down here. Still on page 1, and there you have letter A. We did this one earlier too, and I'll show you real quick. Diagram 3 of 5. So we're on page 1, and we're looking for letter C. It's page 2. This is page 3. So now we can scroll page 3, and there's letter C. Okay, it's real simple. So I realized I didn't mention that before. I apologize. The other thing I was wrong about was I had made a comment about the oxygen sensors and the way the connectors are on them, like you see here. I said that the connectors will touch basically the component in the diagram, not showing any extension of wiring or leads coming off of the oxygen sensor. Well, I was wrong about that. It's not a big deal, but it's just good to know and good to clarify. that one, I was wrong, and B, this is what you'll see a lot of times. So here's your oxygen sensors, okay? And you can see they do have a little bit of a run in between where the connector actually is. It's not physically on the sensor. It's a couple inches worth of wire, and there's your connector. Here's your male side, and there's your female side, okay? So I just wanted to point that out. And then the last thing that I didn't talk about at all, which this is a very good diagram for it. This is, I believe, a 5-page wiring diagram. But what I want to talk about is the numbers on the side of the page. What that corresponds to is if you want to try to follow this circuit, this blue and brown circuit, this is page number 1. So any page is going to be after that, which the way we read in the States goes from left to right, okay? So if you look at the right side of the page, you'll see a number, 12. Well, when you go to the second page, remember I just said we in the States, we want to read from left to right. So on the left side of the page, you'd pick up number 12, and that will be your same wire. Now, if you're looking at your diagram on a computer like we are here, it doesn't matter because it's all right in line. You can follow it along. It's so simple. But if you're out by the car and you have it printed out, this is how you follow along with your wire. Pin 12 or number 12 on a page goes to number 12 on the left side of the following page, okay? Because we read left to right again. So now if you follow that wire along to the right side of page 2, you'll notice there's still a number there, but you'll notice it's not number 12. That's fine. All you do is go to your 4th page in line and you pick and find your number 9. It corresponds with the number before. Same thing, scroll to that side of the page and you'll see it's number 6 and so on and so forth, okay? And by the time you get to your last page, so this is probably a 6-page thing, but nonetheless, you'll go from number 6 to a number 3. Now your last page, you go to number 3, and you can see it'll take you down and feed your oxygen sensors. Okay? That's all. Real simple. Thank you guys for watching. I hope I didn't confuse you. If I did, let me know, and I'll make it right. Till next time. Thanks for watching. And there you have it, folks. Thanks for tuning in today. I hope you learned something with this lesson of reading wiring diagrams. Don't forget to go down to the comments section. Leave your questions, comments, concerns, criticism. I love all of it. Thank you guys for tuning in. Remember to like, subscribe, share, hit the notification bell, all that good stuff. And lastly, just remember, guys, let's get out there and fix something.